So this is like a little customer support video during the middle of some remote tuning on a 3000 GT. And we're at a point where we're doing some wide open throttle fuel tuning. So we've got wastegate spring pressure and leaving timing alone for the moment. So we can establish our knock floor and also just tune in our wide open throttle fuel. So far got through the part throttle and everything's looking great there. So this is just a little customer support video, sometimes a little bit easier to, like a picture's worth 1,000 words and a video's worth 1,000,000. So maybe a little bit faster communication this way. So let's start off by looking at things in the Megalog viewer. Let's see, right now we're looking at data from our previous last data log. So all of our fuel trims were right in line where we wanted them to be on the part throttle. Let's switch over and get ourselves a hold of there we go. Right now, we're looking at the data log from the wide open throttle pull log. So you can see right here on the second swim lane, this little purple line is our throttle position. So we know when it's up here at the top, we're at 100% wide open throttle. And the yellow line is our RPMs going up. Immediately looking at the top swim lane where we keep all our fuel data, AFR error and short-term fuel trim. When these are kind of lined up like this, usually it's a good sign. And then below here, we're looking at this red line is the AFR target, green line is the actual AFR. And when we see these two intersecting a lot like this, it's also a good sign that things are going pretty well as far as our fuel is concerned. So let's look over here at the histogram for this. And right now, we're looking at the short-term fuel trim across the board for the whole data log. Looks pretty good. And when we filter things just for a wide open throttle, and we can see right here, this is our stuff we did in wide open throttle. And so really very, very nice, just kind of staying right there within our desirable plus minus 5% of short-term fuel trim. We've got one other piece of data that we sometimes look at, and this is our AFR error percentage. And here we're looking for things to be around about 100. And this is again just filtered for wide open throttle. 100 means that our AFR is actually matching our AFR target right on the numbers. A little bit under that would be lean, a little bit over that would be rich, but we can see all of these numbers right here are pretty good. And we can see that we were just at a maximum boost on this spring pressure is really right about 14, 15 PSI. So that covers things from a perspective of Megalog viewer, looking pretty good there. And so finally, we'll take a look at the same data log, now running it within a Haltech NSP. NSP provides a lot of great ways to look at data, and I like to look at it in whenever we're doing like a wide open throttle pull, because you can actually run the log and kind of step through everything that you'd want to look at. So just what's going on the page here. We've got some data elements here at the top. Kind of maybe a little bit hard to see, but we got fuel tuning, ignition tuning, temperatures and sensors, knock information, engine states, and so forth. The middle area here is divided up to look at the various elements from our configuration. And then down below, some key things to look at: RPMs, throttle position. This is boost or vacuum, fuel compensation, which is something interesting we want to talk about here. Target lambda, O2, the actual AFR, short-term fuel trim, throttle position looks like you got in here twice, and then injector duty cycle, which is going to be important for us to look at. Okay, so we're looking down here at the data log. You can see right here, the blue line is wide open throttle pulls and the red line is RPM. I'm going to focus it on this second wide open throttle pull here. And just by highlighting it like this, we can kind of get to a little bit more granular view. So we start down here and we'll start to just kind of run this data log on a very slow feedback, a very slow playback, I should say. We see right now we're about 2,500 RPMs. We're not yet wide open throttle, and obviously running a little bit of vacuum. Now, freeze frame right away, before we even get to this, something important. Our fuel composition is showing at 100%. Now, we know that we don't have 100% ethanol in the tank, and as talked about with the owner, looks like there is a problem with this ethanol sensor, so we're going to throw that one away and go install another one and hopefully get proper readings. So since we've got E85 in the tank, and if we're looking down here at fuel composition, makeup down here between the two maps, 10 and 70 or above, we'll be running off of this 70% ethanol map or above. So that's going to use this AFR targeting map. So let's continue to run. Let things go play out here a little bit further, and we're going to see what's going to happen. So again, just at 2753 RPMs. We haven't gotten to wide open throttle yet. And we should just be about getting there right now. There we are, 100% on throttle, right under 3,000 RPMs. We see our O2s are staying pretty much in line with our targets, and our feedback is pretty low. Again, within that plus minus 5%. Boost pressure slowly ramping up. And again, we're just on spring pressure here, so I'm not going to expect this to get above 15, 14 or so in that ballpark area. This is the key one to watch here. Our injector duty cycle is the only thing that kind of stood out to me in this data log that was a little bit interesting. Now, let's see what else we want to point out here. Right now, let's just freeze it real quick for a second. I see our target lambda is 11.1 and our O2 is 10.9. But if we're looking at the crosshairs here, we can see that this should really be at about 11.3. So I was wondering what was going on here. It's something to investigate. One thing I am considering looking at here is this air temp correction. And we can see that this map does have some values in here. Oh, which also brings to point another thing. So right now our intake air temp is 33 degrees Fahrenheit. It is winter time. Just want to make sure that's accurate. And so that is going to play a little bit of a factor in terms of a little air correction from this correction map based on air temperature. I'm not sure if this is how I always want to run this map. I'm going to take a look and see how this compares with what I've done elsewhere and see if that's going to be a factor for us. Anyway, let's get back to running through this back on play, and we'll move back over to our target lambda map. So again, we mentioned we're moving at 11.3 and we're seeing about 11.1. Regardless, our AFRs are pretty much staying in line as we're rolling through about 4,500 RPM right now. Injector duty cycles up to 65%, and our boost pressure is right there at about 14.1, 14.2, 14.4. So that's right around the spring pressure rate. Everything right here is looking good. Nothing out of the ordinary. As we're reaching 5,275, we're noticing our injector duty cycles getting pretty high now. Here we are at 77, 76, 78, starting to push the limit. Now we're over 80 and 81, 82, 83, 84, hanging right around there. Here we are. So now we're already at about 5694, almost 5700 RPM, and we're starting to exceed kind of like the sweet spot. You know, the 85% injector duty cycle is kind of like the limit. So there's a little bit of concern right here. We're not running out of fuel at any point. Obviously, our O2s are staying pretty much where they need to be, and short-term feedback's not having to work that hard. But if our injector duty cycle is coming up this high, it has a little bit of concern. We always see a 90 there. That's something we're going to have to look at and see if it impacts us anywhere else down the road. Outside of that, the rest of this run is just great, and we just finished, came off the throttle, and everything's returning back to normal at this point in time. So that's all we got for right now. I'll talk about this with the customer, and we'll go from there.